I cannot hear anybody on the Zoom, Amy. But apparently you can hear me because everybody just jumped.
Yeah. See, there we go.
That worked.
Here,
Oh, so they're going to try and get that up on the screen.
Yes.
That works. We can hear you.
Oh,
Lovely.
oh, yay.
Okay.
Can't see you. You're a ghost.
I put my video on, but apparently you took your video off. And now it's back.
Yeah, I think they're working on trying to display it in the room screen. So yeah, we have a here, but we have nothing in HackMD. We have one sort of standing topic that Archon is here kind of representing Image Compat Working Group, which they have their own meeting, but in case there are topics around that. Anyone else have topics for OCI discussion? Just here to chat. I know the two people said they might try and there's Brandon. Said they might try and show up here. I don't know if anyone, I can't think of how to pronounce his name. It's not in, maybe it is Antonio from Google, who is a kind maintainer. He and Alexander from Intel wanted to talk to the OCI about the fact that network devices are not in the runtime spec, that, you know, that's all handled. They're not, anyway, I'd love for them to show up because they can probably describe they really just want to focus on the device. It's like ETH0, you know, on Linux, not adding CNI and network configuration and all that goes along with that. They're fine with that being not in the OCI, but so I don't have the background and reasons why, but they did say they wanted to show up here, and if they don't, I did ask them to come to the Thursday call and present that at some point. So here we are. What's up, Brandon?
Good morning from Virginia.
Yeah, I'll be there tomorrow and get home. Do you have topics? It looks like, I don't know if one of those is us, one of the squares, video squares.
I can see you. They like to zoom right in on you right now, but I didn't put anything on the agenda because I figured folks didn't want to come to a meeting and listen to another Zoom call.
Yeah. Well, it's super early West Coast time, right?
Yeah, none of them made it. Things that we've been battering back and forth a little bit lately. I've got a draft blog post out for the image spec and distribution spec 1.1 release. And so there's been a little bit of back and forth on what needs to go into that. And lately in the chatter, we've been talking about what's next for some of the stuff coming up, and especially like distribution spec. So things that have been hitting us lately have been like the tag API, whether or not we want to have a more advanced tag listing.
Okay. Yeah, I saw was that in Slack? You mentioned the blog post. I saw you mention it somewhere.
It was probably in Slack, and I'll go ahead and link it up into the meeting notes here.
Okay. Oh, yeah, I see it there. It actually surprised me because I thought we just did, I guess we had some kind of announcement. Did it mention 1.1, but we don't actually have a blog post yet?
We probably had a blog post a year ago on this, and then we put a release. I guess just because every time we do a release, we do a post on that, but we didn't do like a general blog post for people that don't know as much about the project. So it's trying to be a little more encompassing.
Yeah, this looks nice. So yeah, so this is much more detailed about all the 1.1 changes. Okay. Oh, close. Yeah, sure. We do have Alexander here that I suggested he might show up. So we don't really have, I mean, unless there are other topics, we don't have a ton to discuss. So do you want to talk about that? I mean, Akihiro is a runtime maintainer. I don't, but a lot of West Coast people aren't joining the call because it's very early.
Yeah.
So, but maybe it'd be good to just, if you want to share like the general idea.
Yeah, so hey, Alexander Knievsky, whoever don't know me or haven't met me yet. I work at Intel, mostly about resource management topics. And because of that, it's NRI related, DRA related, CDI related, and so on. So been involved in many of related talks. So what was recently discussed, and that's what triggered me the idea what I wanted to discuss with OCI forum. Antonio Oreja came and asked about to have a network device as something what like CDI or DRA can handle. And at the same time, I saw him opening the issue to, I think, to runtime spec about to have network device as part of like runtime spec. In Kubernetes world, network device is not a container level thingy, it's more pod level resource. And what triggers me to like line of thinking is, shall we actually add to OCI specification some notion about like the group of containers, like pods or sandbox or whatever we call it, but to have something formally which will be describing, here's the group of the containers, here's the runtime specs of it, here's the like this group of resources for this group, like network device, or maybe like some like limits for the memory or reservation for the memory, something what can be part of that, and so on. So practically like formalizing what is current patterns of using containers in the world. Like nobody currently in the world doing like Docker run. Everybody are using like Docker Compose, and Compose is already like group of containers. So I think to bring to this forum, like starting the idea of discussing, shall we have this kind of object? Right now it's just like my thoughts, but probably like if somebody else is interested, we can group together and then create some formal proposal.
So if we're going to introduce pod-specific features like the runtime specific proposal for networking stuff, maybe we can consider introducing the pod in the runtime spec.
I don't necessarily want to call it pod, but some kind of like group of containers, and then figure out what is the best patterns from Kubernetes, from Docker Compose, from any other usages where this group of containers might happen, and then let's standardize them as entity.
Yeah, that sounds good. Yeah, maybe we can do some experiments using OCI annotations in config.json. And if it works well, we can graduate the OCI annotation to proper JSON fields in JSON.
I'm not sure what annotations will be enough for that.
Yes,
Because you need something like higher level object,
Yeah.
which will be a wrapper. So like the biggest problem what I've seen, or like what I can foresee with all of this, is what it's not going to be just like plain list of containers.
yeah, right.
We need to have like, we will have like higher level objects which might contain embedded runtime spec object.
Yeah, right. Yeah.
That's one thing, but then for each container, we need to have probably fields related to lifetime of this container.
Yeah, right.
Because like if we look at the Docker compose, it's simple, like all the containers start at the same time, we terminate at the same time.
Yeah, right.
But when we have like restart policy fields for each of a container, and if we look at the Kubernetes group of containers, we have more complex. Like we have idea of init container, which is like runs before normal container starts until completion. And when we have like sidecars, which starts before normal containers, ends after the normal containers. So if we want to standardize it on OCI level, we need to think about all of those patterns, how to properly
Yeah, right.
describe it.
Yeah, right. Yeah, yeah. So maybe we can define the JSON objects, but maybe we can just marshalize that JSON into a string in OCI annotations, because we may need to iterate some cycles to find out the right schema for objects, and we implement POC for Kubernetes and Docker Compose and others. And if we agree that the POC works well, we can graduate the objects.
I almost think about it as being outside of the runtime spec, because like Sasha said, like there would be it could be composed of multiple runtime specs and then additional metadata information. So I almost wonder if instead of going an annotation serialization route, the start could be just like define a spec. You know, no one has to conform to it, but like, you know, like it almost, I think of it outside of the like the runtime, like a current existence of OCI runtime, because, you know, runtime is really focused on a single container. And I don't think we should break that pattern. So I would imagine there would be, you know, it's like tools on top of the runtimes, or like, you know, this spec would describe how multiple invocations of runtime should be called in sequence. And which would also allow sort of faster iteration on the specification itself, because you wouldn't need to inject it in an annotation. It would just be like a new spec.
Yeah, I see it not as an addition inside the current runtime spec. I see it as a separate object. There is actually one thing which I forgot to say in the beginning. So I'm not thinking it only about like the standardizing the spec of it, but also to have it as part of like OCI runtime schemes, what is used in containerd and CRI. So practically, it's all related to discussions about VM-based runtimes and confidential VMs.
Yeah.
So practically all of them right now are trying to do like different kind of workarounds, what we are not creating VM until the first container arrives. So with proper state management for those schemes, we can have information passed saying like, hey, now we are going to create a group of containers. Here's the descriptions, here's the lifetimes of those containers. So the confidential VM or scheme can say like, okay, well, kata containers, for example, like create the VM of right shape and expect what you will be consuming, like with mount points, with devices, whatever. So it's like two steps thing. Like one thing is specification, and second is enhancing the scheme for runtimes to actually also operate not only single containers, but also group of containers.
So will it include RPC as well? just like TGRPC in continuity.
Yeah, I think in the end of the day, like, yes, extension to that protocol as well. Yes.
Or one could also imagine a world in which it's a specification similar to the runtime spec, but like, you know, an entity like Containerd could use its, you know, a shim could have like aspects of TGRPC to like have like, you know, Containerd itself communicate with, you know, whatever entity is actually starting the pod itself. But then, you know, maybe at that point it becomes a runtime or something similar to a runtime spec where it's just like a JSON file. Instead of having the sort of protocol need to be defined, it could just be, you know, at the similar, like analogous to what a runtime kind of is. It's just a declarative, here's all the stuff you need to set up. And the communication aspect could be handled by a higher level runtime if they decided that that's what they wanted to do.
With Mike Brown, we chatted about that idea some time ago. He said, like, yeah, it might make sense, but needs to look at the details.
Yeah.
That's why I'm thinking like we need to have a broad discussion with.
I think a risk exists in the proposal, and you know, I'm broadly in support of it, but like just thinking about sort of some of the possible difficulties is like, you know, we currently like obviously the Kubernetes community and like the, you know, Docker Compose community, they're not doing a whole lot of communication now, but like, you know, it'll add this additional layer of, you know, for lack of a better word, like bureaucracy to the process of like changing something in either of them, because it'll, you know, take a lot more consensus building among all of the different entities, which is fine. And like we're doing a semblance of that, just kind of like proxied through the higher level container runtimes. You know, like Containerd is going to be peripherally aware of, you know, what Docker composes through a couple of layers, but you know, it would sort of increase the complexity of like, you know, the sidecar initiative in Kubernetes, I found myself thinking of, and like, that was a process of just defining like what sidecars needed to be. But if, you know, we already have like a pod spec of sorts that would also involve, or could have also involved additional, you know, negotiations with the OCI community, which, you know, would have made that more of a complex process. And that's like, could be worth the standardization, but that's like a risk of it.
Yeah, my way of thinking of all of this is what we are right now, not trying to define something what everybody needs to be following or like needs to urgently start to implement. We are kind of like following right now. So like the things are already implemented, what we can just like simply formalize based on the best practices and best knowledge what we're gaining from those projects.
Yeah, right. And like, obviously, there's all of this precedent to like, you know, but all of these communities have a way of making this work. So like, there's plenty of content to base it off of, you know, versus when the runtime spec was being created, it was, you know, they obviously they had some stuff built already, but you know, there was more iteration that was done on top of that. It's a lot longer, older of a technology now than it was then, which could make things easier. But, you know, I don't expect these technologies to remain stagnant either. And like new use cases, you know, are coming up in the pod lifecycle in Kubernetes all the time. So like, you know, it'll make that difficult, which is, you know, again, could be worth it.
And if we are going to formalize what we are already using, do we going to use continuity sim build RPC? Because I think Cryo uses that as well. Was that PR much?
We did adopt it because basically the Kata community was like, adopt this or we won't support you, basically. I think it would be, you know, a preference of the cryo community to not necessarily go with the same sort of API structure and have it work a little bit differently. And I can also imagine like Podman community could take advantage of this, but wouldn't necessarily also do the same. But that's not a hard no. It's just like, you know, if I was to be asked my preference, it wouldn't necessarily be to continue, to adoption V2.
I don't have any strong preferences.
Oh.
So for me, it's easier.
Yeah, I imagine the particularities of how we go about this API or specification will end up looking, in a way that, the OCI sort of started with is like negotiation between, the CryoPodman, world and then the Containerd and Docker world, like that, I think that'll take some negotiation, but definitely happy to work towards that together.
So what do you think the next step is? You want to write something a little more detailed, or Antonio or somebody?
I think I can put something like my thoughts in writing, with maybe some like more practical ideas what I meant about all of these things. And we still need to involve Antonio and the networking guys to see like how we want to represent network in this object.
It's also looping in Kata folks as they, stand to benefit a lot from this proposal. So
Absolutely.
probably having them.
Yeah.
And then, I think representatives from the runtimes will also cover representatives of Signode, who has pretty heavy involvement as well. But inviting, groups of each of the container engine communities, and then Signode, and then Kata, and then network, and, getting everyone in the room and sort of discussing the advantages of something like this and sort of the desires out of it, I think is a good first step.
Yeah, so far, like OCI spec was like the common language where everybody speaks. Like all the mentioned projects. So let's extend vocabulary of that language.
Yeah.
Sounds like you are going to start another working group, right, for
Oh,
this matter.
well, that might be like overkill, but probably like first of all, like I understand it require like formal document proposal, and it require a formal presentation at the OCI meeting, not just like a conversation like we have today. So yeah, that one, yes, definitely needs to be done. Yes.
Because
The result as a separate working group, I don't know. It's
yeah, it's not up to me to decide. I just recently created another working group, and I see some maybe overlappings in your cases when it comes to compatibility, some aspects in there. So
you are from image compatibility group.
yes,
Okay.
yes,
Well, from our team, Patrick
Yeah.
Plukt is mostly following what you guys are
yeah,
doing.
he's quite active there. So
I have a potentially provocative question from folks in the Containerd community. Just curious, in the inverse of what was asked by Akihiro, like, do you think Containerd would consider a world in which, the shim layer of a pod moves away from using TTRPC to communicate with it? Like, do you think like that sort of standard is something that the Containerd community would be, want to keep in place in spite of like a standardized spec that doesn't necessarily use it? Like, imagine a world in which we create a JSON blob similar to a runtime spec. Do you think the Containerd community would want to keep a TTRPC protocol on top of that?
Yeah. So we already support gRPC in addition to TTRPC. So does it work better, or do we need to introduce something more formal?
I almost am wondering like not even an RPC
Yeah.
protocol, you know, in the way the runtime spec, it's not like you're communicating with the runtime spec with an RPC. You're just writing a file, which, you know, has its limitations also, but just sort of probing, you know, if there was a workflow that looked like runtime, you know, you create your runtime blob and then you pass that down to a process that does all the processing of it. If there was a workflow that looks similar where there was a, you know, a shared pod layer that created this pod blob and then pass that down to, you know, and then correspondingly talk to each of the OCI runtimes, like would Continuity wish to keep a TTRPC protocol in that mix?
But what you're suggesting to use instead? Like imagine if it's not TTRPC, what's
Well, I mean, the run, like I find myself thinking of an analogy of the runtime spec, right? Where it's just like a JSON file that you serialize and put on disk and then pass down. He's like, here's my file, create my runtime or can create my container. And then the same sort of workflow, here's my pod spec, create my pod.
But with TTRPC or well, any RPC mechanism, it solves the main problem of like synchronization of events. So like you are sending a message and you are waiting until operation is done. In case of exchanging like blobs on the file system, it means what like you write the blob and then you need to constantly like the I notify or polling the state of that file back to see if something changed inside of it.
Yeah, and that it definitely is a sort of particularity of the runtime spec too, where you like give it the runtime spec and then you just like watch for the PID file to get created or something like that to see, you know, or like wait for the child process to be started. And that's the workflow could look a little bit differently. So, but just, you know.
Yeah, but I think like the whole RPC was exactly to solve that. So instead of like trying to observe some out of band activities, right? You get the exact message back saying like, yeah, well, container is created.
I see. So in your vision, then there would be an RPC protocol associated with this, you know, pod spec.
Maybe I just don't know like the internal details of runtime well enough to judge that. But my thinking was what the idea of implementing this RPC based was exactly about this synchronization of events.
Totally.
And structure it like well structure it what is requested and what is gone well or errored out.
Yeah. And I'm not saying that I'm opposed to adopting something similar if we standardize on that, you know, adopting it in cryo and advocating for Podman to adopt it, but just sort of probing and, you know, while we have some people in the room working through what we're imagining that this will, what will be involved.
Mm.
Like run C and C run implementation, when normal execution is expected to be like exact and input output as std in, std out, std, right? Nothing more. So the streams are actually just wrapping those exec part.
Well, there also are like lifecycle, you know, pod container lifecycle commands. Like you can like tell it to stop or you can tell it to.
Yeah, but it's still in the end it will become like run C exec start. Oh, exec run C start something.
Right. Yes.
Yeah.
Yeah. You execute the command.
Yeah, but when communication between the actual run C binary is like std in, std out.
Yes. Yes.
Yeah.
Or usually just the process ending or writing a file. Like often, you know, you're like, hey, write this PID file when the process is created, and then you do an inotify on that directory so you can catch when the file gets created and when the process is started.
Yeah, but when for simple container runtimes like run C or C run or so on, it's easy. But in case of Kata, it doesn't make to have one executable binary which will be connected to something else using the socket. So it's easier to keep just socket running.
Yeah.
I don't know, like for WASM, like at least like run WASI, I think it's the same implementation. So it's like single process which starts like multiple WASM workloads. So it also doesn't make to have like exact style communication.
right?
Yeah, but these are also some disadvantages because then all your containers are started from the same environment. With the runtime spec model, you can like stuff like integration with systemd, for example, or running in a different C group or namespace. It's clearer because the process starts in your same environment. So, I mean, there is a difference, like the simple model we have with runtime spec with a model that you have a process always running and getting requests. Yeah.
Yeah, that is a good point where, like, you know, on a standard fork exec model in Linux, you have a lot more flexibility in like pre-preparing or like, you know, updating the process space of that container. But that's thinking about a single process space. So like, does that model, do we have similarities in that model with a pod? Maybe not, because we've been working around the fact that, you know, it's distinct OCI runtime calls. You're not like creating a shared, you know, it's not like a shared process space in a similar way. So
yeah. The problem, as I see that with containers, like the single unit is what we call the container. Instead with virtual machines, you need to abstract on the pod. So a container alone, it's not enough. It's like so yeah, the abstraction must happen at higher level to map the Kubernetes model of pods. So it's difficult to fit in the same box containers and virtual machines because they abstract at a different level. Even a container is just in the end an abstraction above different mechanisms. Like, for example, with a container, you can't now with runtime spec just create a C group. Like, you still need the entire infrastructure. So the cut we made, like the cut there is at the container level, but that it's like too low for the virtual machines. Yeah. So if I understood correctly, the entire problem here is that with a single container definition, you don't have enough information to create the virtual machine. You need the higher level abstraction, basically.
Kind of, yes. So, I mean, like confidential containers, like VM is just implementation details, how it's implemented. But what was the common point is what we cannot resize that VM. So that's the only single reason why we want on the creation time to have information about all the containers, what will be inside of these groups of containers, like pod or whatever you call it. So it's not about VM, it's more about what, like the timing and abstractions, what we're talking about.
We exhaust that topic for this meeting. I mean,
From my side, for now, I'm done. I will come back informal meeting.
yeah,
Something.
great. But yeah, I guess the point Peter made is important, that a bunch of interested communities aren't really part of the usual OCI call, and we want to make sure to include them, Signode, container runtimes. So yeah, I guess we just got to make sure we figure out how to do that well.
I've added a new topic to the agenda, which is VTPM specification and support. But I guess Brandon would like to talk first about the blog post, or not?
I was just throwing it out there in case we needed some topics, but go ahead and take the VT. Yeah.
Yeah, because there is kind of interest in this PR that I posted. It's from 2020, and we are just basically wondering what's going on with that. If there is a appropriate review from runtime, the maintainers on that. So maybe because we don't have to discuss this in detail today, I just want to bring attention that to runtime maintainers that there is this PR and it's still valid to add VTPM support. This is a telco thing to runtime spec. Yeah, just 4 years ago.
Yeah, both the issue, run CPR and the run spec issue. Oh, yeah. Yeah, I was just, so Akihiro is the last comment in the PR. Said, should that wait till the BTM spec goes into runtime? That discussion also ended. Well, August 6, 2020, Mrunal.
So maybe it would be better if I just ping the creator of this PR, because I see the last review is from Mrunal. I'm sorry if I pronounced that.
Mrunal, yeah.
Then I will ask the creator what's the status if he's continuing with that PR. Otherwise, maybe we will hijack from my side and try to make this happen.
So this is you're interested in VTPM?
Yeah. Yes.
Yeah, this is IBM research. Stefan, I used to work with Stefan Berger. Yeah, I don't know if they chose a different route or, yeah, but yeah, we should pay them.
Okay, let's do it this way then.
Is this request already defined in the runtime spec?
Yeah, I think in the runtime spec it should be defined in that.
Oh,
There was an examples how it could be settled in there. If you scroll down, there will be a reference to the pull request in the runtime spec.
this one. Okay, I
Yeah.
found it. 9.
Yeah, 920 runtime spec. Yeah, all right, okay, yeah, ping stuff on it. Brandon, anything, blog post you'd like us to look at or looking for?
Mostly
review?
it was just an awareness, and I think I'll pull it out of draft here later on, probably later today, and then give it another week, and then we'll publish it unless somebody has objections. But the post itself
Okay.
was mostly just giving a big heads up of a lot of the changes we've been making in the 1.1 releases of image and distribution, which have been a lot.
Yeah. Yeah, no, thanks for working on that. Got a lot of good detail.
I feel like it's so rare we get the runtime maintainers or people wanting to discuss runtime topics. So I'm just sitting back and letting conversations flow over there. I do feel like we've heard a few times over the years that between image spec and runtime spec, there is a gap of once we define the image spec and then pass it over to runtime, there's stuff that happens in containerd, stuff that happens in cryo that is just not part of OCI at all. And so that discussion sounded interesting to me of what can we do to standardize that process between the two.
Oh, not even 1 hour in. Else have something?
Yeah,
Ready?
maybe because told you already, Phil, about the image compatibility working group, so I can give a quick update because I
Yep.
was chasing people here. I have a talk at Contributor Summit, not so many people join, but later I had quite good discussions about that. So the outcome is people are quite interested in that, especially for telco, edge devices, use cases, HPC, and so on. And they didn't like the idea of proposal B and D. It's not because of artifact usage. Basically, they said it's overcomplicated, and the tooling that is proposed in the proposals is that it's just very narrowed to specific use cases. So we have to work on something much more generic. Maybe it might mean that we don't implement under OCI a tool, just kind of tweak the standards or create a new artifact or something like that, and try to release something more useful. Because yeah, all the use cases that were in the B and D are very specific to first. B is very specific to telco, and D is very specific to HPC and scheduling, image selection, some kind of different perspective that people have in here at least. So I'm going to release a new proposal once I'm back that will try to make it more simple. People like the proposal A and E more, so kudos to you, Brandon, for that. But they said it doesn't solve all the issues. For example, proposal E lacks of standardization because it doesn't change much, because you still can come up with your own custom annotations when it comes to compatibility. So people would like to define more standard way. And in proposal B, when we use platform features, it would be good to have something more than just describing what features the CPU or platform brings, like additional stuff. So my idea is that it should not be a simple list of string. It should be maybe some kind of more complex object, but I guess once I create a proposal about that, we will have some good background to discuss all of that stuff based on this, what I heard. So yeah, just a quick update.
It's a good topic to get the runtimes involved in early on, because what we're really getting at is when you see OCI index, I mean, there are two actual problems. So one of the problems is image selection. When you see an OCI index, how do you select your image from a list of a whole bunch of them in there? And I think that's going to really affect runtimes when we say, here's how you process this list in a much more granular way. It's not just saying, hey, I've got the AMD 64 image, so let me go ahead and pull that one out of the list. We're getting into a lot more granular selection criteria. And there are a lot of use cases been thrown out of look at the network equipment on there, look at whether you got a GPU driver, a whole bunch of other different scenarios that we're trying to handle in here. Maybe you want a TPM or something. And then there's a second question that was thrown out, which was, if we're running a Kubernetes cluster, how do we provision that cluster to run this image? And that's a very different question that's being processed by a very different group of people. And so we've come together as working group trying to answer both of those questions. And I don't know if we're going to come out with a single spec to answer both questions.
Yeah, exactly. And because this is what I'm saying right now, that those telco and HPC examples are very specific to their own like playground and so. So because image selection is quite generic for B, at least, that we have some kind of generic solution for that. People didn't understand why we want to handle the scheduling use cases in that case, because scheduling is a different layer, at least in Kubernetes, right? That you you shouldn't solve this kind of issues on the OCI level. That's what I heard, one opinion about that, which I find quite valid. And when it comes to cluster provisioning, it's pretty much the same story. So we have to build something abstract enough that can fit too many use cases. So basically, I have something in my mind right now how we could do this, to build some kind of specification that allows you to that is generic enough. And if you have a specific use case, like, I don't know, scheduling or whatever like that, you have to come up with your own tool by consuming the abstraction we provide to you. But more detailed in the proposal itself, because
So I just wanted to comment what, like, you don't need to solve scheduling problems, but what you can do is actually to help user to select when, like facilitate the proper scheduling decision. So like very simple example. Let's say I have image which require particular instruction set from the CPU. You can have a tool which will be saying like, well, this is the image, and the tool will write the corresponding pod spec where you will have a specified like node selector, which will be referring to, let's say, NFD labels, which says like this CPU set is available on this node. So this simple tool, but will help customers.
yeah, exactly. I mean, you will be able to provide labels that describe your own images and so on, and you can come up with something that will match against the nodes and so on. But
what I mean is what, like, out of just simple image present in registry, how to create the pod spec.
Okay, this way, that out of this, that appropriate
Yes.
pod spec.
So like I'm simple user, like I'm browsing, let's say like Docker Hub or Query Registry or whatever. I found like some nice application. I say I want to use it. What currently I'm getting is like, here's the Docker run command. But if I want to run it on Kubernetes, it would be good to have a button which says like, hey, this is the pod spec with all we needed like node selector labels, which will be consumable.
I see. So this aspect of compatibility, I didn't think of. Like, you can generate based on that some kind of pod spec or whatever that already points you with some specific node selectors and so on. So yeah, something to think of.
Where's practically will be the scheduling decision for Kubernetes.
Yeah. I mean, in the proposal D, it's a little bit different how it's being achieved. But yeah, I get your point.
We chatted a little bit at your talk, but a problem about using information on the image level in a Kubernetes context is that the scheduler doesn't have any idea like what the image means in a pod spec. So if this is information embedded within the image, then it's like meaningless to the scheduler as of now.
So
but that's exactly what I'm saying about the tooling. So like you can get the metadata out of registry and then convert it to a pod spec. So when the pod spec become like the common language to a scheduler, well, like what we are talking about, how to use that image.
So basically what I thought, you just on the image level, you provide some metadata to describe some stuff. And I would say that's not OCI role to generate some kind of, or bring some tooling that would help Kubernetes schedulers. If I would implement this today, I would say, bring some maybe artifact or some specification that describes your container compatibility, and bring a separate tool outside OCI that reads those metadata and converts that, I don't know, maybe generate the pod spec or whatever with appropriate node selectors. Maybe you could use notation of NFD. There is an idea inside compatibility to use node feature discovery labels to provide on the image side and so on. But this is just still under discussion. So if you have some specific requirements like that, I think it's worth to attend the meeting, and you are here. Just, the image compatibility. Just the idea. Okay.
Yeah, I'm mostly thinking about sort of limitation of the data paths as they stand right now. Like, can't do this today without I mean, you could have a scheduler plugin that goes and reads the OCI registry and admits a pod based on the information that it gets. But then again, remember, like, both Cryo and Containerd have mirroring behavior. So, I mean, theoretically, the SHA is going to be, the same, but being wary of making sure that, the image that is being pulled is actually the image that this scheduling plugin is inspecting would be, could be a challenge.
Yeah. That's true.
For anyone that hadn't looked at some of those specs from the working group, the two very different approaches that were taken was one looked at extending the annotations within the descriptors of the index. And so just add an extra key value pair in there. And then the request was we could have runtimes, Cryo, Containerd, others out there, look through the list and be injected with a user configuration on the runtime that says, hey, this container runtime on this machine prefers anytime it sees an image with these annotations. And so when it looks through the index, it sees those annotations, it says, hey, that's one I like better than the others, and so only pick that one instead of the first one. That's all a question getting ABS. Go ahead. No? Okay. Yeah, Phil, safe travels. So the other one in there that I think Marcin was working on a lot, and other folks in the group, was adding external artifacts that you would query for individual images and then query for the external artifact from the registry outside of the index. And so you pull the index, you pull the image, you query the refers API for those artifacts to figure out, does this individual image from the index match some of my criteria? And I think the use case is very much flip on that one, from being more useful for people scheduling at runtime that might not want to go and do a bunch of those extra API calls on each individual entry in the index, to being useful for people that are scheduling that says, hey, I'm deploying this one individual image. Let me make nodes or find nodes that match these criteria nicely.
Yeah, and on a Kubernetes scheduling level, the difficulty is like any information in the OCI image, like, is like, you can schedule a pod to, or a container to a node, right? And like, regardless of whether or not it has this extended, these resources or anything within that are requested within the index or the artifact or wherever. But you get into this sort of miscommunication between, because like, if the scheduler has decided that this pod should be admitted, then the kubelet's just going to keep being like, please create this pod. And the container runtime, even if it's not ideal, will either have to create it or like enter the situation where it just continually errors. Like, I mean, this is a very active conversation in the, dynamic resource allocation conversation, where it's like, how do you make it so that the failure is happening at scheduling rather than happens at runtime, because that allows for like either the scheduler to choose a different node or for, some autoscaler to create a node that actually has the sort of topology that you're looking for. So it's like very much the same issue, just like, where the difference in is where the information is kept. And the difficulty with this OCI approach is that it's not discoverable from any of the kube components other than the container runtime. And by the time it gets there, it's too late.
I think there's also the risk that the scheduler doesn't have the information about the individual nodes that the node has. And so the node may know more details about itself than the scheduler does.
Well, and that's what DRA is, meant to solve. And the advantage of having it, at that level rather than at the OCI level is it's a user requesting in the pod spec, like, I want this special, device or, extended CPU or whatever. And then the scheduler can tune into that and like ask the nodes, hey, do you have this? Whereas, in this, OCI case, it would be defined by the workload author and in part the person who's running it. But it would be difficult to discover anywhere else.
What I have in my mind right now is that if we decide to release this as an artifact, we could create a cap for scheduler, or have early discussion with scheduler SIG to talk about that, how they could maybe consume the artifact or something like that from the OCI.
There is a very low chance what scheduler will go to a registry to fetch metadata of the image.
Yeah, it's risky for sure. Like,
I mean, it's more about like the whole way how a scheduler is designed. It's not going to communicate to some external entity.
yeah, that makes sense.
So, I mean, the image compatibility, OCI working group, I think is like worth exploring, but I also think it's worth imagining, thinking, obviously this is, I'm coming from a Kubernetes context, so like, I'm not as much tuned into what other, runtimes or orchestrators are trying to do with it, but like the conversation is very much sort of unifying around the DRA model of like, there's a device plugin that advertises some amount of resources and is installed alongside whatever drivers you need. And that advertisement happens to the scheduler, and then the scheduler can actually make decisions because it's aware of what the user requested through the pod spec and what's available on the node through the, the device driver. And that, like, I'm just struggling to sort of see how to connect this proposal to that, which I think is where the community is sort of unifying in this case.
Just idea from top of the head. So practically what you can do is you can have mutating admission webhook, which will on the pod creation time will analyze the image name, go to a registry, fetch the metadata, adjust the node selector or inject the DRA claim to that, and then only admits the pod. So that way is you can automatically get that information and talk to a scheduler in scheduler's language.
Right. And I think that there are ways to work around this limitation, but I guess the curiosity that I have is like, is the work of the image compatibility, massaging the image compatibility on the OCI level, is that work worth it in a Kubernetes context versus just, some other baked solution, like, because it could do that, with an annotation just on the pod spec, right? That wouldn't be defined by the workload author, but that would be defined by the user who's trying to run the workload. And, and in that case, it fits the model a little bit better. So, yeah. But obviously this is a very Kubernetes based perspective. And so that's not going to apply to any other, sort of entity. And so the scope of the OCI is a little bit different than the perspective that I'm coming from.
Yeah, similar thing, like if you want to like Docker run or Docker compose, you need to figure out how is where can be possible implemented.
Yeah, that's why what I said, it's just to refer to this. That's why what I said about keeping some OCI metadata that which are generic enough and consumable by different toolings, and it would be responsible of other toolings to provide a specific format for specific orchestrators and so on. So if you have, I don't know, specification in the OCI about image compatibility that cannot be Kubernetes centric, but has to be consumable by others as well. And if you want to do it, you should come up with other tools that maybe in Kubernetes, this mutation webhook idea would be something good. And if, for example, it's for Docker, then I don't have much information I don't know much about Docker Swarm and how Compose works in that case, but I don't have a good answer for that, to be honest. It's just something that I didn't think of. I just wanted to provide generic enough metadata on the image side that is possible to be understandable by others, and it's not Kubernetes centric.
But that's like the trap of creating spec just because of spec. You need to have like at least one hero implementation which will be consuming that spec. So pick up one of your poisons like Docker Compose or Kubernetes or something, but you need to show at least one customer. Otherwise, nobody is going to adopt our specification.
Yes, you are right. But how to refer to this? I mean, I thought to create specification the way how you express attributes, and that can be Kubernetes centric and other stuff. But so for example, proposal D is kind of open in that people, organizations create their own attributes. And so we have a general specification how you provide these attributes. The attributes itself, the format and everything is user's responsibility. So for example, if I have Kubernetes workload and I have HPC, over the spec, I could come up with my own attributes that could be understandable by Kubernetes. And if there is another organization that works with Docker, they can come up with their own attributes. But the downside of that is you might end up with so many different, yeah, exactly. So it's still under discussion. There's no good solution for that now. I mean,
I will say, when you're thinking about the power that the refers API has been giving us, that if there was a spec for pod spec and we wanted to attach, here's the pod spec for this container image, and then tooling like Argo could just look at it and say, hey, I'm getting ready to deploy this image. Let me pull in those details and apply that as my initial state, and then, you know, map some stuff on top of it. That could work nicely for pod spec. You can ship the Kubernetes YAML file. Docker is doing that today as an artifact up to the registry. I feel like the bigger gap right now is tools like OpenTofu or Terraform, any of those that are provisioning hardware, of trying to package together provisioning the node itself out there as details. But very much what we're getting at is that this turns into a whole bunch of individual specs. As long as each of them have a media type, anybody could pick and choose which one they want to support. It would be interesting if we could get something that's standardized, but it might just be too broad a problem to try to standardize it.
yeah, maybe
From the
media
research.
type, you're right. It's something to consider for sure, that at least from my own perspective, how you provide this specific information to adjusted use cases. So
Yeah, from the refers API, all we need to define is a media type for each one of these different kinds of content. And once that's been defined, that could be something that's registered in IANA or something that's just created by individual teams. Once you have a media type, you're just querying the API and saying, does this image contain this extra metadata attached to it? And you just pull it directly, same as we're doing for signatures, same as we're doing for SBOMs and attestations, other details. So it would be relatively quick and easy to look up, and that way each group that defines each individual media type pod spec is a well-defined specification out there. You just point over their definition and say, hey, here's the definition of their JSON, pull it, run it, deploy it.
yeah, I like the idea. I like the idea. I mean, if you have Kubernetes case, then you could just use what NFD provides you and build specification based on that and appropriate media type. So that's a nice idea.
The downside of the idea is that it's too simple. You don't need a working group for that. You just need to tell people put content up in the registry under a refers API with a specific media type, and you're done. While we've got some of the other people in the room, I'm thinking cryo and, you know, the runtimes and whatnot. Are there thoughts, concerns, and whatnot from the runtime side when you're actually doing image selection from an index? And how deep are you willing to go in that process in terms of round trips when you're looking through an index? Do you want something that comes back immediately? Do you need something that can be more detailed, and so you don't mind doing extra round trips for each individual image you're checking to see if it's good enough? Are there fields that you're willing to use, not willing to use? I'm just kind of trying to get a scope of concerns there from that runtime side, because we haven't been talking too much.
Yeah, I mean, multiple round trips definitely, or like, you know, the more round trips, the less ideal, I would say. I mean, but that's a pretty simple answer for you. I would say I'm not opposed to additional ones if it is expressive and then useful in the context that we're running, but you know, we already have, you know, at least one to get the manifest list, maybe, you know, and then another to, you know, pull down, you know, obviously the pull down the layers, it's a difficult part, but obviously the fewer the better, but you know, that's not to say that it's like I'm opposed to any additional ones if that's the, you know, the best solution for it.
The thing that got me concerned about it, as I've been doing so much work on the refers API, is that the refers API lets you change that content as the image gets, as the lifetime continues, someone updates something down the road. And I feel like runtimes are more interested in, hey, I've picked this, I've run it, I've deployed it. I shouldn't have to go through that whole process again a second time when I try to deploy the image a second time.
Right. And I mean, in the cryo case, because we're, you know, only looking at Kubernetes, like we're not even going to check the image, the registry again, if we're not told to, you know, and that's up to the kubelet. We're not even making that decision. So, or rather up to the pod author, but the kubelet will tell us. So it's, you know, we're not even in the position to like recheck, unless told to. So if that updates, then we wouldn't know and we wouldn't update in some cases. So it couldn't be something that a workload author could rely on without making sure that they configure their pod spec correctly.
It maps to concerns I have, so I feel like we're on the same page on that one at least. I think it creates concerns from Arsene though, so
Yeah, because when we spoke, there was this idea that you can, sorry, I missed a word, influence. You can influence image selection in container runtimes by pulling, for example, additional artifacts. So I understand that that would be something more complicated. So what I proposed in container a meeting that basically we let people to come up with their own image selection algorithms or something like that over pluggable ways. So we keep everything as it is by default, but if somebody has very complicated use case, they can bring their own way of image selection stuff, how it being made, and that moves also responsibility from runtimes, maintainers or software itself to users. That users decide and they are responsible for that. So if something goes wrong, it's just their responsibility.
Yeah, I'm trying to think of how an equivalent thing would happen in cryo because we're not as modular by design. So I think it would be kind of difficult to do a similar thing. I also wonder, I mean, in that case, does, you know, if you have a plugin that is going to do custom, you know, image selection, what is the, you know, what is the advantage of defining a spec at all? Because it's not going to be standardly followed by different plugins. It's just good. Like you might as well just have an annotation on the image and then this plugin will just like, be like, I want this annotation because this is the resource I care about. You know, having a full specification or artifacts or, you know, something added to the specific field of the image. That process would be useful if it's something that is standard, is like going to be in, you know, the OCI image spec for pulling, you know, like a requirement of that. But if it's just going to be customization, I don't see the point in making a specification.
So because we want to come up with specification, not only because of image selection. Image selection is just one additional thing, and it's coming from HPC. It's basically not my use case in here. But we don't want to build the whole specification only because of image selection. It's just something additional. So we thought how we can use already some stuff we are working on, like this specification, and how it could influence also image selection stuff. So how people bring those plugins and what they are following would be basically up to them. If it would be even possible from my perspective that not to use the stuff we are building itself, they can just bring their own things, but there's some risk on that, like security stuff and so on, how you bring those plugins in a safe way, if it should be in 3 out of 3 or something like that. So that was just an idea how we could use it. But for image selection, my personal preference is the proposal A, that you bring annotations on the runtime side and you use what is provided on the image side and see if that matches or not. If that matches, you pick appropriate image. If I said something wrong about that, Brandon, then correct me.
I think you're saying everything right. I just know from some of our use cases before that there was a request of how can I change the selection after the fact. And I don't know if it's necessarily selection, but just change the artifact spec, whatever we define after the fact.
I would almost think that it should create a different manifest in that situation. Like I think it would be materially a different image if you're changing the sort of resource desires or whatever of the image.
That
'cause
was
I
the
wouldn't really-
direction the proposal A went. We
Yeah.
went that direction and we basically said, and I think this has concerns for some of the people working on this. I'll get to their specific concern in a second, but the proposal that I made was you just make a new index. You don't have to make all new images. You can make
Right.
a new index that's just that one JSON manifest that has a couple of extra annotations and you're done. You don't have to rewrite layers or any of that stuff. The concern that was raised was that some people are also looking to do this. They want to extend images that are not on their registry. They want to point up to a Microsoft server, something like that, pull down an image, run it on their HPC cluster. Maybe it's an NVIDIA server they're pulling all their images from. And they want to put their artifact for how they configure their runtime on a local registry without pulling the whole image down. And that turns into a different problem.
Yes, that is a different problem. And I still am. Yeah, I see. But I mean, is it within scope of any of the other runtimes? Because I know Cryo isn't trying to do this. Like, what is the expectation on the runtime once the annotations or whatever the metadata is changes? Are they expected to re-pull the image and start a different container, or are they expected to, just wait until a new container is started up, or like what is the hope there?
I'm not sure we get into that like with other container runtimes. For sure with container D, I think, Brandon, we didn't discuss that. What is the expectation if something changes in there? We were just trying to figure out what makes sense or what are the concerns in there, but we didn't get there.
Yeah, I guess from my perspective, if I understand the use case of having an external image, but it's also not, terribly difficult to move an image to a local registry or whatever, and then annotate it in the way that you want. And I'm kind of the opinion that like mutable annotations as a use case is strange because there's no event-driven sort of like pulling mechanism in any of the runtimes where it's waiting on an image changing to, well, I guess Podman sort of has this, but it's just periodically checking. It's not like, there's no event on the registry or anything. And so the use case, I don't know, the additional complexity of like imagining a world in which the annotations are changing in place for, a particular image. Like, I don't really see the advantage if you can just, take an image on the Microsoft server and pull it to your local registry and annotate it in the way that you want so that, your container runtimes pull it, select the correct one, especially with image mirroring in, I believe the majority of the major container runtimes.
I'm a big fan of that approach, but I'm also the person that writes a lot of the tooling that does that image copying, so I'm slightly biased.
Fair enough.
I mean, it's bad we don't have Vanessa today because she could bring, I guess, very good their perspective very good on that subject. So, but for sure on Monday we'll go back to this discussion when everybody from the compatibility group is present.
We do have Mike Brown that I think has just gotten up in the Texas, so hour behind the rest of us here, or more than an hour behind everybody there.
Well, I was up at 3 a.m. for the
Makes it even harder.
intros,
Good morning,
and I
Mike.
fell asleep around 6. Wait, everybody.
We have been discussing earlier today, we were discussing a lot of the runtime ideas around, is there room for some kind of notation for a group of containers that we could start to specify within OCI, thinking of how pod spec and other things are out there today for defining containers. So we bounced around that topic. We also bounced around some other cryo stuff, but then just now we've been talking a fair bit about the image compatibility working group. So I think that catches you up to at least the current discussion.
Makes sense. Pod's been around for a while. It'd probably be a good idea to have a group of containers. You know,
It
I'm a
feels
big fan. I've been
It feels
working
like
on
there's a gap.
sessions for a while.
Yeah, it feels like there's a gap between image spec and runtime spec that we don't have
Yeah.
a solid definition. And so you get tools like Cryo, Containerd, and others that are all sitting on top of that, that there might be some room for some standardization in there.
That makes sense. So you're thinking more at the cry space as well, or
I will defer to all the
a
people
pod
in the room that know this
API
better than me.
and a spec.
It would be underneath that. I mean, the idea is like, you know, a layer basically injected between the higher level container runtimes like Containerd and Cryo and above the OCI runtime. Like, you know, think about your shim basically.
Yeah.
Like some standard at that level of the stack, but a shim per pod instead of, you know, per container.
You thinking about it from a Kubernetes perspective, or would this be more generic than that?
This is an OCI meeting, Mike. We're talking more generic.
Just so
Yeah.
can we have more pod states than just running stopped?
Well, I mean, the idea is to standardize at a lower level than Kubernetes, and then, you know, but like use the wisdom that we have from implementing pods in Kubernetes, and then also that, you know, Docker Compose broad and Podman pods and all of these other sort of like layers to sort of standardize around that.
Makes sense.
Is there anything more on the image compatibility we want to chat about? All the microphones go down. You guys are done with that topic. All right, Marcin and I have more discussion to do on Monday, I think. So we'll reset on that one on then.
So Peter, were you going to open up a work group for that or a proposal?
This is Sasha's work actually. So he's
Awesome.
putting together a document, and then we'll iterate from there.
Yeah, Mike, my fault.
Yeah. I'm just along for the ride. Well, we lost the person who was formerly sort of moving the meeting along. Does anyone have anything else they wanted to talk about?
The only other formality I have came from Amy before she ran out the door. She left me a message saying, hey, the next in-person meeting is Container Plumbing Days. So for anybody that's going to be
Yes.
there, I think that is co-hosted with the Open Source Summit, I believe, like a pre-event for that one. So if you're going to be there, that will be the next in-person for this stuff. Otherwise, I'll just open up for any other topics.
That may be it.
Has flew all the way to Paris to have a 90-minute talk. No, yeah. I hope the event's
Right.
been fun. Go ahead.
Oh, just wanted to say thank you.
Cool. Thanks, everyone.
Yeah, thanks, everybody. Mike, you get an extra 30 minutes back in your morning. More time for breakfast.
You can take
That
a
was
nap.
easy.
All right, folks, I will
Mm.
go ahead and close this one down from here. So in case that helps them in the room, I don't know what the AV side over there has to worry about, but have a great rest of your event and see everybody next week on regular Zoom calls. And hopefully folks make it in person for the Container Plumbing Days. Take care.
Okay, thanks, bye.